Hi, I'm helping with section 5.3, and this is on page 264, and we're doing number 10, A, B. And so in the textbook they have a lighthouse that is shining a light. It's shining it in two directions, this way and this way. And then there's a shoreline here. And the lighthouse is 500 meters from the shore. This angle here we can consider theta. And then this one is 90 degrees, and this distance here is d, from where the light is shining to where it is here. Now we can imagine that the lighthouse is rotating this way, but it doesn't really matter because as it comes through, it'll change distance. And so the question is, determine the equation that expresses the distance d in meters as a function of time in minutes. So normally we would think this angle related to this distance related to this thing. So I'd have tan theta equals the opposite over the adjacent. So I'd have d over 500. Now this angle, it says it's going to go, now just to talk a little bit more about theta, theta is going to equal 2 pi, it's going to do a full circle every 2 minutes. And therefore, I can put that as my angle in terms of time. So this occurs every amount of time. And so essentially, my theta is going to equal pi t. So every minute, it's going to do 180 degrees of rotation. And so if I put that here, I get tan of pi t equals d over 500. And then I can say that 500 times tan pi t equals d. Now, as I was graphing this, I'm just graphing it with technology, but normally right at what would be 45 degrees, tan would be 1. In this case, I essentially have an A value of 500. So it is at a quarter of a minute, it'll be rotate through 45 degrees and be at 500. And then we see here, right at that, every time it's going, the light is parallel to the shore, we have an asymptote. And then it's the next light is coming from another distance, and then it goes through there. And so this will be 1 unit right pointing at the shore, so the distance is 0, and from there. So essentially, it goes from the distance is humongous with the asymptote, it gets closer and closer to 0, and then it gets further and further away, and then it hits that next asymptote. So that's how the graph works as far as distance as related to time, with the angle thrown in there as well. Hope that helps.